Hey everyone.
Ew.
Hello.
Okay, you guys hear me okay?
Yes, we do.
Yep,
Yeah,
sounds good.
sounds good.
Cool. Jason, what kind of dog you got there? Ha!
Oh,
He's cute
Nice.
Oh gosh.
and wants to say
It's an
hi.
Aussie and a
and
Corgi.
friendly.
Adorable.
Yeah. They don't behave as well as Carl, so I can never bring them. I wish though.
Yeah. Okay. Well, we are on to the last module. The last when I say last module, like the last of teaching. The capstone is technically the last module, but that is all sort of presentation, or that is all implementation, and you kind of working on your own along with your team on a specific project. So there won't be any more learning. Well, I mean, from me, you'll be learning a ton as you try to figure stuff out. Um, so this last module is all about backend programming. The backend programming is like a huge thing that can mean many different things. And we're learning full stack development, but full stack development for web applications. So we're focused on building web applications, which are tools that you get to through your web browser on your computer or on your phone, which is like um, I mean, that's a huge thing, right? So you can build a company with that. Um, so yeah, there's a huge scope to web development, and it's the main thing I do. So when it comes to backend development for web development, you're mainly learning about databases and servers, and then you'll also hear this term, super like overloaded term, API. So you'll hear API all the time, and people will mean um, many different things when they say that. So we'll go through and learn a little bit more about what an API is specifically for web development. So let's talk a little bit about where like like what we're dealing with when we're doing backend development, and just talk about some of the high level concepts related to it. So far, you guys have really mainly been working with um, the client in this diagram here. And when I say client, I mean like the browser. So client slash browser. So most of what we've been doing has been here. And you write HTML, CSS, and JavaScript to be able to make stuff in the browser, to make websites in the browser. Now you've dealt with, where'd it go? Just disappeared. Does anybody know what just happened in my diagram?
I think someone might have cleared the board because it seems like we all have
Okay.
access to draw on it.
Okay, maybe I can like block. Just don't clear the board. Whoever did that. I'm surprised it didn't let me go back though. Okay, we'll try this again.
Try Command Z.
Well, I like closed the board already, I think, potentially. But I will try that next time. Okay, database, browser, and then I don't know, remember what I used for server before, but let's go with this one. Okay, so we've been mainly here, and we need to start. Man, why is this thing flickering? We need to start doing more complicated things that are like actually useful. So I mean, everything we've been doing so far is useful, but you're very limited in what you can do. So you, with what you've learned so far, you can make like websites, like informational sites, and we've been building like the coffee shop, right? But you can't actually order coffee. Like, so by just building a website that you go to, no one can send, if you're the coffee shop owner and you want to know about somebody's order and you make a front end website and you put that out on the internet, like how can someone contact you? How can someone send you like, hey, I'd like to order coffee, or like send me a bag of beans, or whatever else you'd want to do. So there's no way to do that with what we've learned so far. So whenever you want to actually start doing more complicated things, you need to start doing things on the back end. So take the example of ordering coffee, for example. So somebody loads your site, right? So they go to your URL, coffee.com. I've actually never been to that website. I wonder what's on that website. So you go to, coffee.com, and that loads up for you, right? But like thousands of people might be going to coffee.com, right? So when we have this like one browser example here, there might be, tons of people that are all going to that website. So you've got like tons of instances across a bunch of different computers of people opening a website in their browser, right? So think of Amazon.com. Like, just think about how many people have Amazon.com open on their computer. So somebody, so someone's opening their laptop, going to that URL, and then you are like hitting a server to get the web page, right? So there's this like initial load of the web page itself. And so you guys have dealt with the server, but it's mainly been to load the site. So whenever we do like live server, like you run live server from VS Code, that's kicking off a process that's just simply going to serve the React code or the HTML code so that you can load it in your browser. Okay, so there's a bunch of, that's funny. So there's a bunch of browsers out there, and they're all talking to, we're just going to say there's one server, but usually nowadays there's like a bunch of different instances of a server, but it's all the same server. It's all the same code, basically. So they're all talking to this server. Let me go to lines. So, all these people are making requests to this, instance of a server that is owned by coffee.com. So they are making requests over the internet to a particular server. Does anybody know, like, when we make a request over the internet, what protocol we're using?
HTTPS.
Yeah, usually nowadays is HTTPS for the S meaning secure, or encrypted traffic. So does anybody know, like, whenever you go to coffee.com, what HTTP requests you're doing? What type of request you're doing?
Forget.
Yeah. So every time you go to any particular website, so if I go to coffee.com, I like went to a URL and made a GET request to that URL, which is getting routed over the internet, hits a server that, you know, is associated with that domain, and then gets a response back. So there's a request and then a response. And in this case, it was like a successful response that we got back from the server, which is what's called a 200 OK response. So many of you maybe have heard that word 200 or 200 OK. That means a successful request was like the server received your request, understood what you wanted to do, and gave you back what it thought was the right thing to give back. So that you do all the time. Like whenever you go to a URL in the browser, just by default, that is always a GET request to whatever URL you typed in. Now, whenever you want to make an order for a coffee, so you've went to coffee.com, you've received the website back, you've clicked around on the website, you clicked on like a coffee that's like add to cart. Then you like go to checkout and you say, I want to buy this coffee. So whenever that happens, you have to let coffee company know, like, hey, I want to order, here's my address, here's my money, right? Now, like the whole money processing thing is a whole separate thing, but like essentially that's what you need to tell them. You just need, here's, you know, my address so you can send the coffee to me. So you have to send some information to the coffee people. And whenever we do that, we still do it over HTTPS. Like that's the way that we talk over the internet. But in this case, instead of a GET request, it's called a POST request, which is like, hey, I want to send you information. So in this diagram here, I'm mainly demonstrating the initial GET request. But if this person wants to order coffee, then they would say, hey, I'm going to send, in this case, it's going to let me type, you know, post, and then it's going to be some sort of URL. It's going to be like https://coffee.com/ usually we'll put like API /coffee/order, you know. So you'll make a post request to some URL that the developer that works at coffee.com decides upon. And then they'll expect you to send some data with it. So there'll be like a body to the request. So normally when you make a GET request, it's just to a URL. That's all you need to provide. But when you're doing a post request, you provide a URL and some data in the body of the request. And the way that almost everybody sends data over the internet now is with JSON, which you guys might have heard of before. So JSON. Some people say JSON, some people say JSON. Either way, you can call it whatever you want. But that is a string representation, because whenever we're sending information over the internet, it has to be basically a string. Sorry, let me pause for a second. So JSON is like a way to represent JavaScript objects and arrays as a string, so you can send it over the internet. But you can think of it as like, basically I'll just send an object with all the information I need to send to order my coffee. So if I need to send my address, and in the data here, I would just have like address, and it would have like street and city and state, and it would just, you know, the information needed to be sent. So yeah, when we want to actually order the coffee, we have to make that post request, and then the server will see that and be like, okay, well, who is this that's ordering the coffee? So that's where authentication comes in. You know, you have to log into sites typically, right? So that's another whole back end and front end concept of being able to log in. But assuming whenever you're making the request, they know who you are, so you've successfully authenticated, then they'll say, okay, great. So you want the coffee, and then they'll do some payment processing potentially. So they might already have your credit card on file. A lot of people integrate with a provider to do this. So most people will use like Stripe, if you've heard of that, or some other payment processing company. And this is where the term API will come in a lot. So me, coffee.com, I've made my website and I've made my API, like my server, that has all of my logic for processing coffee and everything like that. But then when I need to do something complicated, like send an email or do payment processing, I might use somebody else's API to facilitate that. So you might have heard of like Twilio or SendGrid or something like that. Those are like text messages and email providers. Because like think about how many emails you get from a company. So you order the coffee, and then you always, everyone is so used to this, get an email that, hey, we got your order and your coffee's coming. So like whenever they receive the request for the coffee, they're going to hit Stripe, potentially if they use Stripe, to process your payment. And then if that's successful, then they'll have to do some sort of inventory thing that they've managed themselves, right? So they'll have a whole like inventory set up. But then if all that goes well, they're going to be able to send the coffee to you. They know what you want. They process your payment. They know where your address is. Then they'll like call an API to say, hey, send an email to this person and, you know, say we successfully got their order. So your server is sort of this like central processing unit of the like logic of your company, of the business logic of your company. And so, you know, your server is dealing with all the people that are opening up browsers and talking to you, but then it's also going to be dealing with a bunch of other APIs for various different things. It just depends on what your company does, on what you would need to do, right? So you might have a Stripe API for payment processing. You might have, you might have SendGrid for email. Let's just leave it at that for now. And so your server needs to go talk to those things, and so it will facilitate that communication. So it will handle talking to Stripe and talking to SendGrid and facilitate that for you. So you have to have this sort of central processing unit whenever you're doing any sort of, you know, company web app or any sort of business process, because you need to have control. As coffee.com, you need to have control over, you know, does this person have the permission to do that? So there's like a big permission boundary thing, which is why I'm kind of calling this a central processing unit, because it knows who's trying to talk to it, and then it decides based off of the permissions of that user, and you know, different business logic, what it should then go do, and it kind of handles all of that. You know, like you as the person in the browser can't talk directly to Stripe, because you could then do something nefarious, right? Like you could be like, oh yeah, I did pay, so just give me the coffee, you know. So like the server that the company owns is kind of that thing that's deciding, you know, what is allowed to be done, and kind of managing that and coordinating that. So then last but not least is the database. So, you know, we need to be able to store information and retrieve it later. So, you know, if we only have everything just in our browser, for example, so think of the example of a to-do list. Like you maybe you guys have prototyped a to-do list in your browser, and you add a to-do and you can see it in the browser. Well, then like once you refresh the page, it's gone, right? So you guys have probably dealt with all the time, you know, you refresh the page and everything you've done is gone. So if you're using a to-do app, you want it to sync and you want to be able to come back to it later and to see that information. And you want to be able to do it on your computer and add a to-do. And then within seconds, you want to pull it up on your phone and see it on your phone, right? So the information that you're giving to some sort of app or whatever it is that you're dealing with, company, that information has to be stored somewhere, not on just your devices, but on their system. And that's where a database comes in. So databases are these massive, you know, things that store a ton of information. And so everything you do, so if you've ordered, you know, from coffee.com 5 times, there's a record of all of that stuff in their database. So this person with this ID ordered coffee on this date, they ordered this bag, and then they went and did that again 5 days later, right? Or whatever. So if you've ordered coffee 5 times, they're going to have 5 entries in their database with all the details about that. So that then also, if you ever go back to coffee.com and want to see your order history, you'd be able to see, you know, back as far as you want, all the orders that you've made, right? So they are storing information of who you are, not in a nefarious way, just like here's your email and your name and your profile picture, and everything sort of has an ID associated with it, like a unique identifier. So you'll have a user ID, and then all the different stuff that all the activity that you've done, they're storing in the database. So just think about, like, if you do social media, like how many database entries you have in all these companies' system. Like everything that you see when you go to those sites is all stored in the database, and being retrieved from the database to show it to you on the page. So if you think about this case of, hey, I want to see my order history from my browser, I'm going to the order history page, right? So in the browser itself, that might be like, some text. So if I want to see my order history, the URL might be like https://coffee.com/orders, right? It could be as simple as that. Or it might be orders/history or something like that. It's just, you know, what URLs show what page is all decided by the developer that's working on it. So it's like, you know, the more complicated the site is, you know, the more URLs you're going to have to make. So they might get longer. For a basic website, you might just have like coffee.com/home/menu/contact/ you know, orders or something like that. So, you know, we'll go to that URL in the browser and it will you know, load up that page for us, right? So that we can see that page. But then that page is going to make a request to the server to ask for my orders, right? So it needs the data from the database for my orders. So we'll initially get just the data to show the web page, but then we need to get the data from the API. And so there will be a request to the server. And this might be get, so it'll be a get request in this case as well, you know, https://coffee.com/API/orders/history. So usually when the data that's like that we decide, like the URL that we decide to use in the front end, often will kind of closely, not exactly, but closely resemble the URL that you use for your API endpoint. So that's where this loaded term is coming from, API. So when I make a request to my server, the coffee.com server, the one that I'm developing, we'll sometimes say that's an API request. And an API request is usually a request to the server for just data. So we're going to make this big API. That's what we're going to be learning about over the next few days, like how to make an API, which is just a bunch of URLs that respond with data. So you know, we're making our coffee shop site, so we're going to need to make an endpoint. This is an endpoint here, this URL, to respond with our menu, to be able to accept an order, to be able to see people's order history, right? These are all API endpoints that we need to write and create that will respond with that data, so that our browser can request it, so that they can then show it to the user. So we'll make this request to the server. It'll receive that and it'll see, oh, hey, like this person's logged in, it's Zach. He wants to see his order history. So let me go fetch his records in the database. So it receives that request. The server will then talk to the database. This is the only thing allowed to talk to the database. Like you cannot talk to the database, like client database. Cooper, quiet. If the browser could talk directly to the database, then it would just be able to see whatever data it wants, which is an issue. So the server has to say, oh, who is this? I know who it is, so I'm going to query just their data. So it is, hey, give me Zach's order history, and then it responds and gives that to the client. Okay. So you've dealt with the browser quite a bit. Now we're adding two new concepts. Server that provides an API to your browser for the data that it can ask for. And then database that stores all the data that the server is talking to get the data. It's also putting data in there too, right? So whenever I say, hey, I want to order coffee, the server's like, I'm going to make a record of that in the database that they ordered coffee, right? So, so if I went too fast, here's the main thing to understand that we're going to be learning. There's two kind of major concepts. There's an acronym here that you're going to learn. So all of this is basically boiled down to what's called CRUD. You may have heard that term CRUD, which is create, read, update, delete. So that's what you can do with data, right? So you can create it, you can read it, you can ask for it, you can update it. You know, updating would be like I made an order, or updating would be like, you know, I've logged in, signed up for Facebook, but then I changed my last name. So I like make an update request to change my last name in their database. And then delete the record, remove it from the database. So these are the main sort of operations of a database that you can do. You can like create, read, update, delete. And then each of these operations that you can do within a database that all databases support. There's another synonymous term for this in the HTTP world, which I don't know if there's actually an acronym, but it's get, post, put, and delete. Those are the different supported HTTP methods. Get, post, put, delete. So which one is associated with read of the HTTP methods? So it's either get, post, put, delete is synonymous with read.
Get.
Get.
Yep, get. Delete is delete. That's an easy one. Create, does anyone know which one create is?
Post.
Yep, post. And then update is put. So, you know, why they decided to call I don't know, actually. I've never looked that up, why it's called put and post for the HTTP method. Instead of just create, but there's all these, whenever you're talking about the HTTP protocol, you know, which is how we send information over the internet. Those are the main methods available. There's a bunch of other ones, but these are the main ones that matter. And so there's the request type itself, but then there's a bunch of different status codes associated with all these that you'll see. And so I already mentioned one. Does anybody remember one of the status codes that I mentioned?
200.
Yeah. So 200, there's the code, status code 200, and then the status like message, which is in the case of 200, just okay, like okay. Everything's okay. And then you'll see different status codes and status messages for different methods. So if you make a GET request to an endpoint that you don't have access to, because you don't have permission, like you've logged in, they know who you are, or you haven't logged in, they don't know who you are, and you try to hit an endpoint that you don't have access to, you'll get a 401 unauthorized response. So you'll see status code 401 and then message unauthorized, just you're not allowed to do this. Or if you're posting data and it successfully creates the data for you, then you'll get a 201 response back. Instead of just 200, you'll get 201, which means, hey, we received your request and we successfully created the information that you wanted us to create. So there's a bunch of other status codes. Does anybody know, like, whenever something horrible happens, like just like we know just something horrible happened, we don't know why? Have you guys ever seen that status code?
Full.
So 404 is a good one. That means not found. That one is not as catastrophic. They just make that might be like, hey, there's some sort of you don't have to do it this way, but you know, if I was looking for orders that I for coffee in December of 2022, well, maybe I didn't have any, and so potentially maybe they respond with 404, not found. Like, hey, there's none that were found. But a lot of times people would still respond with 200 in that case, just because they were successfully able to look and respond. There's just no data. So normally you'll see 404 if you because you can just type in whatever the hell you want, right? So I could type in coffee.com/API/schmorders, and it would say, hey, that's not found. I don't know what URL that is, right? So that's usually what they mean by 404 is like you typed in a URL that doesn't exist. But yeah, I saw somebody mention it in chat. So 500 internal server error is where like just the shit hit the fan. And like unhandled exception, something went wrong, the code has a bug in it, basically. Or like the server's down potentially, but most of the time you'll see bad gateway for that, which means like it just like never responds to you and it like times out basically. Okay, so that's like, if you want to be a web developer, you've learned the front end stuff, so you can make sites now, and you've learned how to make requests to APIs with React, and now you need to learn how to like do the back end, like business logic and storage of data. So most of that stuff is all associated with, these kind of, you can boil it down to that idea. You're really just like creating data and updating data and getting data. And then potentially in the process of creating that data, you might need to send an email or do some sort of computation. but yeah, we're building web APIs to help facilitate and make our browser client more sophisticated for it to be able to do more complicated things and actually support the business, basically. Okay. Might have gone kind of fast. Any questions?
With the like HTTP codes and everything, do we just find those in our dev tools? Pretty straightforward, or is there somewhere else that we should look for those if we ever need to?
Yeah. When you say, I just want to make sure I know, what do you mean by dev tools? Like in the
Like-
console, like in the browser console thing?
Yes.
You'll be able to see in dev tools, like, so like, for example, if we look at this site and go to the network tab, let me zoom in a little bit. So this should all make more sense to you now. So if you open DevTools, we mainly have been in the world of elements and console, right? So elements, JavaScript, or sorry, elements, HTML and CSS, console, JavaScript. Network is like, here are the requests that your browser is making. So when you load the page initially, there's a request it makes to get the page. But then when the page loads and all the JavaScript runs, it might then decide to make additional requests to the API to get information. That's changing a little bit, but that's how most websites work right now. We're starting to see more and more server-side rendering of web pages, which is like kind of funny because that's how we originally did it. And then we stopped doing it that way. And now we're back to doing it that way. But that is kind of like a whole new sort of initiative that's happening that's just like not quite solidified enough to learn about or teach. So like that, I'll talk more about that, but there's kind of like a huge sort of sea change happening in web development right now. That's related to server-side rendering and stuff like that. We're going to be using Next.js, which I'll talk about here in a minute. That is a part of that sort of sea change. And you might hear of other frameworks like Remix that are doing things like server-side rendering. You'll hear it, and you'll also see it on React. We'll talk about that, but don't worry about that quite yet. It's kind of like a new thing that's coming out that's going to take another few years before it's mainstream. So anyway, sorry, network tab, right? So your browser is making requests to the API to potentially get additional information, or to send information. So whenever we load this page, the first request is like, you can see here is like to the website, right? So I originally did coffee.com, but then it redirected me, which is a particular response that then the browser knows to just go to that page instead, and it just does it automatically. So we ended up at Peats.com, and so that's the URL that we requested, https://www.peats.com. Normally you don't need the www. And then you can see here status 200, right? So status is 200. And I can click on this and see here's the URL, here's the request method. It was a GET, status code 200 OK. Peats.com resolved to an IP address, right? Like so there's the domain name registry service that tells you, like, hey, that's what you ask it. Hey, what IP should I go to for Peats.com? And it's like, hey, here's the IP address, 7598.49.125, port 443, which 443 is the port that is secure, the HTTPS port. So this here is like, you guys go to localhost :3000 a lot, right? And that resolves to 127.0.0.0.1, which is like the loop back address to your computer. But when you actually want to talk to something over the internet, then it's going to resolve to some IP address, and here's an IP address, right? So there's the request, and then that has a
Zach,
response.
all we can see is your whiteboard.
Oh, shoot. Thank you. Okay. All right. All right, let's start over. So, Pete's.com. Here's Pete's.com. Like, so I opened the network tab in the dev tools, and this is where you can see the requests that the browser is making. And then you can see this is the first request that the browser made. If you kind of like go to a site, open the tools and like refresh it, it's going to make a ton of requests. Every website makes like a ton of requests, but you can scroll up to the first one, which is the one that like loaded the site, and look at that. And so here's that first request, and you can see the URL that it went to, and then the status code and the request method type and everything. So you can start looking at that. And then a lot of times it'll eventually make a request to get, so you can see it's like loading some JavaScript here, a JS file, which is all stuff it needs to kind of render the page and like make it dynamic and stuff. Then eventually it'll probably, it's like tracking, this is like a tracking site to like see the activity that I'm doing. I think a different site here so you can see it. Okay, so if we go to reviews, it had to, like, I went to this site, I loaded the site for me. It's loading an ad, and I asked for reviews, right? And so it loads like a few different reviews for me, and I can scroll through them. Well, if I like keep scrolling, eventually they'll have to load more, because they don't load like all of them, like every review that they have on the site at one time, right? So that's where the concept of like pagination comes in. So whenever I hit next page, it has to get more data to show it to me. So when I click next page, I would actually like change the page. I mean, so you can see, there's like a ton of requests happening right now, but let me see if I can actually find. Sorry, this might take me a second to actually find. It might take me a second, or I might not have enough time to find the data that's being used to show the reviews, but what you can see on the right here is like it should look like a JavaScript object to you, and so, but it's JSON. So this is like the data that's coming back from the API that the website's then using in some way. Okay, I may not be able to, but like basically to show these reviews, it's receiving back an array of objects that have like the genre and the album title and the artist and the reviewer name and the date that it was reviewed. So it's like receiving all that information from the database and then rendering it on the page. Okay, so we've got about 15 minutes. I want to show you all like just a very basic server that like one that you can write yourself. So so we've learned like JavaScript in the browser. We've learned a little bit of JavaScript in Node. And so Node is like, you know, what we use to run JavaScript on our computer. And just like how when we run JavaScript in the browser, there's like a bunch of different things available to us to do within that we can import and use in that context. Like we can use the window and we can, you know, we can query for the DOM and things like that. We can interact with the page. Whenever you're running JavaScript in Node, like you can interact with the file system. And then, you know, one of the main things that you can do that is what made Node so popular is you can make a server, right? So you can interact with the internet. And so that's like a big part of Node is you can import the HTTP module from Node and then make a server. So that's what we will do. So I'm not going to go through writing all of it. I'm just going to pull it up here so you can see it. So this is just a JavaScript file that I called server.js. And then I am importing the HTTP module here. So that HTTP module is like provided by Node. It's like built into the Node language. And like HTTP meaning like be able to do stuff over the internet. And then this code here is just a variable that says, here's the host that here's the host name, which in this case is just going to be my local computer. So I'm just going to listen on localhost, and then the port that I want to listen on is 5,000. You can choose whatever port you want. I mean, not any number, but roughly any number. So it could be 5001 or 5002 or 6000 or 7000. It's kind of up to you. There's a few conventions. Like most of the time people run like a browser server on 3000. So that's why you're always going to localhost 3000. It's just a convention. And then when we want to write a server, we'll often use you'll see 5,000 a lot. Okay. So this code here is creating we're basically defining the logic of the server. So whenever someone tries to talk to us, what do we want to respond with? We have to write that code. So we have to decide what information to send back. And so here we can, you'll notice we call this HTTP import, and then we call create server. By the way, this is just like the super lowest level way to do this. It's like it's like much more nowadays we use all these like frameworks and stuff to make this easier. So you might have heard of like Express.js, which is one of the first Node server frameworks. We're going to be using Next.js, which I'll talk a lot more about Next.js. But Next.js is this like full stack framework that lets us do React and APIs all in like one package. So it handles just making full stack web applications a lot easier, kind of unifies all of it. So we'll be learning that. And that makes writing API endpoints very simple. But this is like the low level way to do it. Like, okay, so we call this create server method on the HTTP import, and then it gives us through this callback function the request and the response. So we say, hey, create server, and then it says, okay, I'll make the server for you. And then every time someone tries to talk to you, I'll give you that request so that you know what they're asking for. So you can see like what method they're hitting or trying to use, what URL they're hitting, what headers they send along with the request, which we'll learn more about request headers later. And then I'll also give you this response object so that you can decide how you want to respond. And then so you just do that, and then I'll take care of responding to them for you. So that's what you can see here. I've got this callback function here, and it receives the request and the response. So that's what these two variables are: request and response. And then this is basically just we have 3 different endpoints that we make in this particular example. One is if they, so we're not looking at the URL at all. So there, any URL that they hit, you know, we don't care. We'll go ahead and respond. If it's a GET request, so you can see I'm saying if the request.method is a GET request, then this is just the syntax for it. Send back a 200 response, tell them that it's going to be just plain text that I'm sending back to them, and then just give them the message hello world. So that's the syntax to respond with the text hello world. If it's a post method, do the same thing, but just say hello world post. And then if it's not a GET or a post request, then just tell them, hey, 404 not found. So that's all that I'm doing. It's just very simple, basic responses to requests. Okay, so I define my server. That's all my server does. Doesn't do anything else. And then after I've defined it, I then tell it to listen. So most of the stuff that you guys have dealt with is either browser-based stuff, which just sort of runs forever, right? Like as long as the browser's open, like it's sort of running and waiting for you to click on things and stuff like that. Or you've ran like a Node script and it runs and then it exits. So like, you know, you've got like a few different steps and then it finishes. For a server, it runs forever. So you like will run this script, and since it's a server, it needs to stay up and listen forever. And so that's what this command does. And so this script won't exit. It'll just like keep running. So here it is. Let me run it. So I need to navigate to where this script is. And so I've got the server.js file that I wrote that I just walked you all through. And then to run it, does anybody remember what I have to do to run it? Like what I have to type here?
It's a npx.
npm.
Close. So I didn't make a package JSON yet. That is like normally what you would do is you would make a package JSON and then you would have like a npm run start command that would do something. But yeah, so I don't have a package JSON yet. So, you know, we don't have an npm command available to us. Like if I just need to run a JavaScript file,
Just
plain
run.
Jane. So what's the program we use to run a JavaScript file?
VS Code or Node.js.
I thought
Node.
it was Node.
Yeah, so Node, right? Yes. So we want to run Node, and then we just give it the file that we want to run. So Node server.js. Like if you just want to run a JavaScript file locally, none of the fancy stuff that we've gotten into. This is the way you do it. Node and then the name of the file, or the path to the file, which in this case it's in the same directory that I'm in. Okay, so I ran it. You can see it logged, server running at the expected address that I set it to. So that address and that port. And then you can see it's still running. So it didn't give back the terminal to me because the server's listening and it's a running process and it's just waiting for requests. Okay, so like what's going to happen if I put this in the browser? So I take this URL and I put it in the browser. Based off this code here, what do you guys expect to see?
Hello world.
And then, so why?
Because it's a request.
Yeah, so what's the default request type in the browser?
Yeah.
So whenever you go to a URL, it's a GET request, right? So I put this URL in the browser, 127.0.0.1, port 5000. So the browser makes a request to that URL, but it's a browser, so it always makes a GET request whenever it's coming from the user and someone's putting it in the URL. So it does that for us. It makes that request. This server's listening there. It receives that request. It sees it's a GET request, and then it responds with just the text, hello world. So yeah, we can go to our browser, we can go to that URL, and we can just see like the browser just simply renders what it gets back, right? So it got text back, and so it just shows us the text. If it had received HTML back, it would go through and render the HTML and show that to you. And then we can also open the DevTools on this to look at what happened. This is a very, very basic site. So like it hits that URL, it gets back the text, and it doesn't really have any other requests to make. Now browsers always also make a favicon request, which is like to show the icon for that site. I don't have that. Actually, just responding with hello world for the favicon request. But yeah, here's the request. And you can see here's the URL we went to. The method was get. It responded with 200 OK, and the response was just hello world, and that's it. So we're like no different. Like we were just looking at another website, right? That made these requests and responded with stuff like no different than what we just did. So we get back this text. Now, how do we get like hello world post, or how do we get not found to show up in this case?
Can we just go to a different port?
If we went to a different port, then we're not going to get so if I just change this to like 5001, for example, nothing's listening on port 5001. So it says it can't be reached. So it didn't get a response back. Right. So I want to hit the server that we wrote, which is at 5000, but I want to get it to respond with one of these other things. And it's not looking at the URL. So I can't just change the URL because it's not even looking at that at all. It's just responding to every URL that I go to here. It's just going to say hello world too, because it's not trying to look at that and do anything based off of that. So the only thing it's discriminating upon is the method. So I need to send something that's not a GET request to hit one of these other parts of the if statement. And so like, how do you make a post request? So sorry, the short answer is like, you can't do it in the browser without like writing a website yourself that does it, right? So we, as developers, we often need to make API requests so we can see what it gives back. So a lot of people use this tool called Postman that you guys can install. And I have it installed in VS Code. Like you can add the extension Postman in VS Code, which will then let you write whatever request you want. So I can make that same request here that we made in the browser, which is a GET request, and then see the response. So you can see it's responding with hello world. So it's just the exact same request. But Postman lets me change the method if I want to. So there's a lot of methods here we didn't talk about, but the main ones that matter are post, put, and delete. And so I can change it to post. And same URL, same port, but now a post method. And in that case, I get back hello world post. And then I can use a method that's not available. So delete, we didn't write anything that would handle the request for delete. So it's going to hit that else part of our if logic and just say not found. Yeah, so that's like the main thing that we're going to be focusing on learning over the next few weeks is, you know, how do you write these different endpoints that respond with data? It's not going to be text that we respond with, it'll be JSON. So we're going to be sending JavaScript objects basically. And then, so how do we write all those endpoints? How do we integrate with them on the front end in React? Like how do we integrate with our endpoints once we write them so that we can get the data that we want? And then how do we store that data in a database? How do we put it in there? How do we get it out? So that's what we'll be learning. Cool. All right. Sorry I went over. I will send some stuff in Slack for you guys to read before Saturday. And I'll see you Saturday.
Sweet.
Thank
Thanks,
you.
Zach. See you Saturday.
Awesome. Thank you.
See you all.